Okay, I'm Gary Greider. I'm from Los Alamos. I'm going to be running the next panel, but first I want to introduce Dave Montoya. Dave is a Tech Futures lead for HPC at Los Alamos for software. So he worries about the software environments in the HPC Center at LANL. And recently, workflows became a bigger issue for us because the amount of cost of infrastructure as opposed to the cost to the supercomputer itself, the percentage has changed radically. From the mid-90s, maybe we were spending 4 or 5% on everything but the supercomputer, and now we're spending close to 35% or something like that on everything but the supercomputer. So it's become a really big deal, and we've tried to figure out how to pull that information into our procurements that we're for procuring our systems and our infrastructure and for budgeting and everything else. And so Dave got the unfortunate task from me to try to figure out how to handle this, and he's done a really good job of it, and it's catching on within the DOE National Lab sector. And so we wanted to have him come give a talk about how his methodology works and how he's done this workflow documentation for us, and then it'll lead into the panel next, and we have several speakers that will be talking more about this. So without any further ado, Dave. Presenter view.
All right. Thanks, Gary. Let me see how this, there we go. Okay, as Gary mentioned, the way we've been doing RFPs has transitioned over time. If you kind of look way back, a lot of the RFPs were done very prescriptive. We basically said we want this to be done this way, this fast, this big. And as time went on, we sort of transitioned a bit, so to the point where we said, well, we've got problems to solve. Kind of help us solve these problems. What would you come up with as far as a solution for what we're trying to do? Well, I think we're kind of coming towards the end right now where we're actually starting to say, you know, let's help you understand what our workflows are so that you can kind of help us actually really understand where things are going, and we can kind of all start communicating to that effect. So what we did is we went through and we've got a 2020 procurement for Crossroads that we're in partnership with Sandia. It's Los Alamos, Sandia, and NERSC to kind of put this thing together. And for the first time, we put together this workflow white paper that's attached to the RFP to try to kind of start this communication process and try to get people involved to try to describe what we're trying to do. So part of this is that journey. As Gary said, we started looking at this. This is a journey through it. I'll try to not stay in the application weeds too much. But part of this is, and the journey's not over yet. So I think part of this is we're looking for feedback on this process. I think the panel is basically revolving around what, you know, is this helpful? What else do we need? How do we kind of continue to move forward and kind of get to where we want to go? So to start with, wanted to talk a little bit about why are we talking about workflows? And in a way that started about 1.5 years ago, Gary and I were at a workflow workshop. And the first thing we saw is, well, when they started describing workflows, it's all about frameworks, it's all about distributed computing, it's how to shepherd an application into a new environment and get optimization. And we looked at our environment and said, well, that's not really where we're at. We don't need that. We know our users aren't ready for big frameworks like that. So we started doodling around, and of course, Gary would kind of doodle from the application up to storage heaven, and I was looking down at the application weeds. But out of that, we started getting a couple of ideas and concepts that we wanted to kind of continue to run through. The other thing that came up is there's a lot of issues going on, or efforts going on with at NSA. There's fast forward, design forward efforts. There's the Office of Science, XStack process, and projects. And another colleague of mine, Josip Lonkarek, and I kept talking and said, well, these things are getting complicated. As we go to exascale in our world, there's a lot of interaction of things. I mean, things are going to be more tightly interacted. There's more communication. There's more relationships between system components and applications and things like that. That's a big driver. The other thing, and Gary's mentioned this before, is economics are driving us to kind of look in different areas as we kind of put systems together. So it's kind of very important to see where the economics transitioning to in the larger environment. So that's one thing that we need to kind of be aware of. And in a way, if you look at workflows, it helps us kind of define what those areas are and be able to kind of set the stage for analyzing some of those areas. So one thing that we came up with out of this whole process was a premise that we needed to consider everything a workflow. From the tiniest little piece that runs inside a system to how an application works to how data moves, everything's a workflow. So kind of armed with this premise, we kind of started going out and said, well, let's go initially kind of focus on the application stack. Because the one thing about the application stack, that's the one unknown that we really don't have. You know, for most parts, when we're doing an RFP, we're trying to buy a system. We're prescribing things, we want to buy an environment. We can't create a system and then say, well, we want to put an RFP for applications to come. You know, it just doesn't work that way. So we really need to understand where the applications are going. But that's not to say that there aren't other stacks like data stacks and system stacks. There's a lot of runtime things going on, everything else. But we're focused, at least with this study, on the application stack. So looking at that, what are the application workflows? And we started talking to people. We started pulling people in and say, well, what's your workflow? What is a workflow to you? And it sort of kind of came out like this. You know, we started, people had their own perspective of what a workflow is. You talk to somebody on the application side, you found this. You talk to somebody on the storage side, this was really important. You talk to the guys that played around with the nodes and the network, and this was their world. So this kind of, you got this kind of feeling that there's a lot of things going on, we throw it all together, but if there's a way to communicate and connect the dots a little bit more, that would be better. So one of the whole ideas is we wanted to kind of create a structure where we started to kind of pull the whole piece together, understand the whole. So then we said, okay, what are the important drivers, at least for the case we were doing right now? And we looked at what industry partners are we working on, and in our case on the NNSA laboratories, fast forward, design forward, things like that. They're looking out 5, 10 years, and they're trying to run things in a simulator. So they want workflows, but they want workflows so they can kind of plug into the simulators and kind of see how things are going to work. So there's one of their drivers. Others are the vendors, like the RFP that I mentioned for 2020. That's a little shorter term. Not that 4 years is that much shorter, but it's a little window, and there's certain things that we know from the technology perspective that are going to be around there, so we can actually start taking a look at how things are going to be working in 4 or 5 years. The other area was on the application side. You know, what do the application users actually think about, and how do they see the system working, and how do the developers look at it, and what do they need as this transition happens and as time goes forward? So that was one group, and then come production computing guys, the people that actually have to basically bring up the system, manage the system. In many cases, when we started going out and saying, well, go find out what the users' workflows are, people said, well, go talk to the production consultants that take care of the users. They know all about the users' workflows. But when you actually talk to them, they say, well, we really don't understand it. We get called in when there's problems, so we see this little piece of the workflow. We don't understand the larger piece. So there's a gap that we kind of found as we started talking to people, that nobody really understood all the pieces or where things kind of fit in. But this also kind of started bringing in that concept that as we get more complicated and as things go towards exascale and things get tighter, what are the interface points that are going to be important for communication between systems and applications and components and everything else like that? And this kind of looking at a workflow from a broad perspective kind of said we can use that to kind of identify those things. And then lastly, it's kind of documentation and providing a map and putting that perspective together. So as we talked to people and started looking at that, what does the application stack look like? This is a picture that sort of emerged. And it all depended on when we started talking to people. Initially, we started at talking to code developers and application teams, and this is a picture that they painted. You know, in many cases, it's the application layer. What happens within an application? Well, then you take that application, you go up a layer, and it's part of a job sequence and a job run that has different parts to it, has a different use case, has a different scale, and all that. And then ultimately, we kind of ended up going up to a larger layer as far as over time. This is a description of the pictures, but then also down below, we kind of got into kernels and what happens inside packages within an application. Now again, you have to kind of look at this as a perspective from the types of applications that we run at the labs, like at Los Alamos, or a lot simulation type runs. So this isn't descriptive of all applications, but it kind of gives us a window into the types of things that we're running. So, you know, kind of once we had this kind of map of how people saw their world and the different layers that were related, we said, well, we need a taxonomy to try to describe that. So we actually kind of sat down and started looking at the pictures and said, what do we need to communicate? What do we need to collect? What's the processes that we need? So we kind of went down the road of trying to put a taxonomy together. And this is kind of like a description of what we came up with as far as our taxonomy goes. It's kind of simplistic, but we wanted to kind of capture a few things. Like we wanted to be visual, we wanted to show flow, we wanted to have a concept of the data layers that were involved from an application perspective, and then things like, you know, and you've seen this before, hot to cold, and how durable are the data components within it, and what are the relationships. So you can kind of see, at least on that little cutout, you know, you got the boxes. One could be an application, one could be a setup process, and the lines kind of point to data that resides somewhere in the data stack. Well, that relationship could be described, and we could find information and collect information about it as far as how large is it, what do you use, how does it work, all that type of stuff. So we kind of went along with that, and then started putting together collection templates and how are we going to actually collect that data. And we actually ran into problems later on that I'll kind of describe later. So I'm going to run through those 4 stacks real quick. The campaign pipeline layer. This was a derived kind of layer that we found, because we really didn't see this as we talked to people. But when we got to the end and kind of looked at how we as an organization kind of managed large runs, we saw that there was a 6-month period that we called a campaign, and there was proposal put in, and people would get projects assigned to it, and they could kind of run along a 6-month campaign. Well, as we started talking to people, we saw, well, the way they do this could effectively change or impact the resources or how they do it. And come to find out that most projects and teams had a process where for different chunks of time, they would run small investigatory type runs, and then as things went further and further, they got bigger runs, larger scales and all that. So in essence, if this is true, it doesn't really tell us much more than saying that the storage systems and the system resources, the nodes and procs, are being used differently at different points in time. So what could someone use for this? Well, instead of a 6-month time period, they could potentially cut it into 3-month and have a kind of a phase thing where you got projects overlining and kind of spread that kind of stress on the system across it. We don't know if this is true, but it kind of gives us that idea. Getting down into what we called layer 1, which was the job run layer. This is what I think most people consider the traditional kind of workflow components. You know, there's an application is running, there's some analysis, there's a setup phase, there's interaction with storage and memory. Like in our cases, in the setup box here, that could be as simple as I'm going to change the input deck and I'm going to run the system, run the application job through, or that in itself could have its own whole workflow that could take 2 or 3 weeks doing mesh development, mesh generation, input deck generation, a few other things. So it could serve as two kind of forms. Like in this case, we've got a large application there that pretty much is interacting both with memory, but also has a checkpoint restart. So if you can see that little red dot on the top, it says, well, and occasionally there's a checkpoint restart dump that kind of gets put into storage and may recycle. And then there's possibly small files that are used for analysis, and a larger file that could be put in, used for visualization later on down the road. And then later on up into archive. So that was kind of like how we described that layer. We have like the NVRAM burst buffer layer. None of our applications are using it, but we wanted to kind of show that as a perspective for use. Now layer 2 gets into the application weeds, so I kind of won't go into it too much, but one of the things about our applications is it's a multi-physics type applications that we run. So in the case of our applications, they're complex, they're big, they have a lot of packages that are basically physics packages. There's let's say four main ones there. Some are service packages bringing data in from storage into memory, and then it kind of runs through. The workflow at this layer is really the time steps. So it's down at the microsecond layer. As it transitions across packages, there's issues that come up as far as like data structures in the transition. There's issues between packages. In our case, examples of some of those packages are things like the hydro, radiation transport, maybe equation of state libraries, things like that. But things that started coming out through our discussions that are opportunities for the data layers above is that in some cases they have databases that kind of sit in that memory layer right now. And potentially is that opportunities for that to transition at a different layer. When you're running applications that may use 16,000 or 32,000 processors, there's a lot of opportunity for how do you actually manage and utilize data and layers and packaging it across components. So it kind of gives us that idea. We haven't kind of come down to this area much as far as analysis, but we wanted to kind of describe it. The last one is if you take any one of those packages, we saw another layer below it, which was we call layer 3, which is down at the algorithmic layer, loops. This is where the architecture is kind of really important. Compilers may make a big difference at this point. How the architecture works, the nodes are structured. So that's down at the real performance analysis layer. Not too much as far as the data, but it feeds up later on. So why is it important to have all these layers? And one of the reasons we went down, even if we're not attacking all at one time, is we wanted to kind of have a holistic view of the whole environment to understand what the relationships are. Because what matters is the relationships across these whole environments, and to be able to identify them, characterize them, maybe collect information, provides that bigger picture of how things are going. Also, if you kind of do assessments across, then you actually start seeing areas for opportunity, where the economics are, potential bottlenecks, but it also kind of gives us a forum for people to communicate, whether you're on the application side, the user side, production side, industry side. So that's kind of what we saw. So how do we use all this stuff? And so what we said is, let's take this taxonomy and start putting that white paper together for the RFP. At least from the Los Alamos side, we kind of use some of this process. So we focus on the top two layers, really what we call the campaign layer and the traditional job run layer. And we focus on what we called Campaign 9 and CLO, which was a 6-month period where they kind of put proposals out, projects and project teams get assigned to it. And in our case on CLO, that was both Sandia, Los Alamos, and Livermore participants. So there's people from all three sites. And then we went and tried to characterize the layer 0 and 1 at Los Alamos. And what kind of came out of it was 4 project suites that were predominant through that whole process, and they included the EAP, LAP, Silverton, and the VPIC suites. So as we went and talked to the different people, and the collection process we used initially is really just interview. We went and talked to people that were running this. We asked them what they were doing, how they were doing it, why they were doing it, what the issues that they had. So we put together a collection template, and then through this collection template, we slowly kind of generalized it as we talked to more and more people. And we came up with, kind of high points of what is this application really doing? What's the scale that it's running at? We tried to then, for that application suite, put together what's the general workflow that it is, and then basically take each of the lines that come from the boxes from those what we called activity areas up to the data areas, and then characterize them. So in the detail, and there's a page that relates to the application box, and in there it talks about the checkpoints, how long it takes, how often, the amount of memory that's used, and try to characterize this as best as we could through that process. Now, after this whole process, we would go back and change it. In fact, I've got a lot of notes to go back and collect more information. But this is what we used, what we got this first round. So we took that, and out of that, we kind of summarized the 4 application suites into summary workflow white papers, in essence, about 3 or 4 pages that described what they did. And then out of that, we kind of fed that into the process of putting together what we call the Apex RFP workflow white paper, which was a collaboration done it was Brad Settlemyer from Los Alamos, Cy Hammond from Sandy, and Chris Daly from NERSC. and they kind of put all the information that they could gather and try to put this description together. And I think the vendors have been kind of using this to kind of look at it and kind of come back and forth on it. So part of that is the main thing that kind of generalized out of that whole process is there were two basic workflows that kind of came out. One was a simulation workflow and one was a UQ, uncertainty quantification type workflow. This is the general SIM workflow. So you can kind of see it looks a little bit like we had in the earlier ones. And maybe not all the boxes are perfect, but in general, it captures the essence of how that type of a workflow works. So in that white paper, and there's a URL at the bottom that kind of points you to that direction, is there. But in that paper, there's also a table that, and to me, that's kind of like the more exciting one, because it actually talks about each specific application or application suite that was captured as best as we could. And it sort of describes information about that specific suite. And in many cases, it's very, they're all POSIX right now, whether it's end-to-one or end-to-end type data. And we try to capture a lot of information. And the interesting thing is this has been a really good working tool between the vendors to kind of go back, because they would look at it and say, well, based on that, you need this. And we will go back and say, well, no, that can't be true. So we'll go look at the numbers and try to collect different numbers. Or else they'll say, well, if we had this information and this information, that would give us a better picture. So it's been a really good area to kind of co-design and work to see how do we actually describe workflows that everybody understands and gets the right picture of where to go forward. So that's kind of helped. And in this case, if you look at our workflow wiper, it is very data focused right now. I know, and that's mainly because that's where we are in this time for 2020. If you look further on, fast forward, design forward, they're looking out further in the future. I mean, they're looking at a lot more things, like they want to know, are you memory bound, and how's the algorithmic process working down at the layer 2 layers and all that. That's not what this workflow white paper is. This is mainly focused at the data layers. But another interesting thing that kind of comes up is, at least for the Los Alamos applications and down at the data layers, you can actually kind of see how there's different ways that they use. They do checkpoints, that they use their memory, what they write out for analysis and visualization and long-term storage and all that kind of stuff. So it kind of starts creating that pattern that things are the same, but they're also different. So how does this help as we kind of go forward? Well, it kind of helps start to set up that co-design between users, application developers, vendors, and all that, because in many cases the users may not have realized what they're doing. They are kind of tied to try to doing it that way, but when you start giving people the understanding and comparison to what other applications are doing, then you actually start potentially changing behavior. You're getting this co-design center, well, if we can do this, we can get you this, or if we can increase performance this way, we can do that. So it's kind of setting that cross-communication process. The other thing is validation. The one thing I think we did find is our collection process was very, very manual, so it's all interviews. What people actually do in the wild is a little bit different. So what we really need to do is start tying in things like monitoring structures to collect information that tell us what the workflow is at a large scale. We had some of that with some of our apps. We could actually, on one of the suites, we had all the history of all the checkpoints. We can go back and say, well, Tim did a 4.7 terabyte checkpoint in October, and it took him 10 minutes. So we can start putting that information together, but we don't have it for everything, and we need to kind of go back and outline what is that information so that we can actually start doing a kind of long-term kind of workflow analysis, get enough data to do some of the analysis. So that's part of that. But then this also kind of sets the stage for how do we start thinking about the future workflows, because we looked at it as things are now. But having that process allows us to kind of start setting the stage for, well, if we move this around, or if we start doing it this other way, we can actually start working with the developers to kind of start transitioning and taking a look at where things transition to in the future. So kind of looking at it from that point is, how do you put that big picture together? And we started coming up with this concept called workflow performance. Because traditionally, when people do performance, they say, well, what's my data? What's my I/O performance? Or how are my functions doing in my application? I want to optimize that. So they're looking at small layers. But when you kind of start looking at it from a larger level, you start looking, well, what's my workflow doing overall? And it may be different from this platform to this other platform, or if I have these options on, or if I take these parameters. So one of the things is we again looked at the layers and we said, well, what's collected and what's important up and down the scale. So if I'm looking at possibly what's happening at a job run layer, well, I may need information that gets collected, that can be collected down at the lower layers that are normally used for performance analysis, but in the case of being able to kind of look at my overall picture over time, I may need some of those pieces of information to kind of look for long-term analysis. So that's kind of like that whole concept. And we're looking at that from how to integrate monitoring and workflow analysis and communication all together. So that kind of covers most of that. I did add one other slide, and this is mostly to kind of look at it from the storage and data perspective. Is in this last description that I ran through, this journey that we did, it was all about the application. So the application as it interacted with the data stack was very simplistic. We had layers of memory and so on and so forth. But what is really the data stack? What is it? Is there a taxonomy needed for the data stack? I think right now what you see is most that comes from integrators and vendors that say, well, we understand all your issues and here's the solution that we have, and this is sort of like our data stack. But we don't have a taxonomy to describe that. And what are the potential needs in that area? You know, as we start looking at where we're going, some of those detailed things, and maybe software oriented, are, you know, load and bleed APIs. There's potentially distributed computation across things, transactions resilience. I saw something that Rob Ross put together last week, and he started describing these use cases where they kind of looked at how data was being used within the applications, whether it's just managing libraries or potentially databases like we saw in the application, that kind of puts these potential data services out there. And those are things that might be described as how they integrate into the solutions. So there's a lot of things that could be done there, but that's for another day. So last slide here is just the parting thoughts. And this is really capping, what is this workflow taxonomy giving us? And part of it kind of gives us that whole idea of a map and knowledge, so we can actually see how things are connected. Again, this is done for the application. Now looking at workflow performance, that's starting to kind of look at collection points and how do we start looking at things from a holistic level so we can actually see whether things are moving in the right direction. So that's another important point. Again, the transition in economics is going to be a key factor, but all this together starts kind of giving that point of giving us an overall larger environment, a more data-driven environment to start starting to put these pictures together of how systems and components and applications and users kind of work together. So with that, thanks for listening.